Greeting to Sir Muhammad Firdaus bin Aminuddin, our DCC20063 Engineering Survey Lecturer. This is my practical test. My name is Vanessa Ere Jeffrey, metric number 05DKA19F2030. For this practical test, I choosing a Leica Nova TM60. Leica Nova TM60 is a new monitoring solution come with a strong promise real-time information and report you can always rely on, helping you make informed decision in time and on time, be it settling, fleecing, shifting, sliding or any other change of state, and you will have it under control 24 hours a day, 7 days a week. The robust, precise and enduring TM60 come with the world's longest ATR plus range, half-second automatic aiming accuracy, advanced imaging and the longest continuous operation. Combined with the Leica Geo MOS monitoring solution, you will be able to react to complex demands of any project, be it continuous or periodic. The decision is easy, maximum safety, minimum risk and half-second at a time. For specification for this total station, number 1 is lowest downtime. Leica Nova TM60 is set out to give you peace of mind with the longest continuous operation in the field, the longest maintenance intervals, and no data gaps due to the new Leica GeoMOS Edge. Number 2 is Leica GeoMOS. Leica GeoSystem Automatic Deformation, the monitoring system, help monitoring customer quickly understand and react to complex demand of monitoring project with the necessary flexibility, up to 3 million without the need to do adjustment to environmental conditions. Specification is auto-learn. This GeoMOS fader allows the instrument to automatically choose, aim and measure monitoring prism with an enlarged field of view of the ATR+. The detection of monitoring target can now be done automatically and remotely. For precaution safety, number 1 is watch out for erroneous measurement result if the product has been dropped or has been misused, modified, stored for long period or transported. Number 2 is because of the risk of electrocution, it is dangerous to use poles, leveling stuff and extension in the vicinity of electrical installation such as power cables or electrical railways. Number 3 is be careful with pointing the product toward the sun because the telescope functions as a magnifying glass and can injure your eyes and or cause damage inside the product. Number 4 is high mechanical stress, high ambient temperature or immersion into fluid can cause leakage, fire or explosion of the battery. And last, for precaution safety is if the product is used with accessory, for example mast staff pole, you may increase the risk of being struck by lightning. For basic operation, detachable type, there has top handle, collimator, camera display, eyepiece ring, eyepiece, laser indicator, plate wheel, SD and USB cover, display panel, keyboard, detaching knob, leveling screw, focus ring, instrument head mat, battery latch, battery pack, telescope tangent screw, telescope thumb screw, clamp screw, tangent screw, base plate, DSC objective lens, DSC SD and USB, objective lens, laser plumage, Bluetooth antenna, RS232C connector, and the last one is circular view. Next is how to set up the total station. Every construction project relies on accurate measurement, and the total station is one of the most important pieces of surveying equipment used in the industry today. From setting building corners to sighting utility lines, the sophisticated instrument provides surveyor with an important time-saving tools. However, regardless of how technologically advanced the total station is built, it takes a competent surveyor to ensure and accurate the precise instrument station set up. Let's take a look at the steps involved to properly set up and level the Trimble total station. Next is procedure set up the total station. It is very important for every surveyor to have all of their equipment ready for the job ahead. Step number 1 is gather the survey equipment, stack and tools. We must have tripod, tree branch, total station, survey controller, power cable, communication cable, battery pack, survey controller, stake with nail and survey market, and the last one is hammer. Step 2 is establish a new temporary benchmark. Within our project, we typically need to establish a new point of reference with a temporary benchmark. Using a small nail tape into the center of a wooden stake, pound the stake into an as flush as possible with the ground. Step 3 is set up the tripod. While holding the tripod, loosen the tripod leg clamps and extend the tripod up to the head beyond your neck and chin. Straighten the leg clamps. Spread out the tripod leg evenly, about 2 to 3 feet for each leg, and enter it over your benchmark stake. The top of your tripod should be mostly level and parallel with a horizontal plane. Step 4 is attach the trip bridge and cross level the tripod over the benchmark. A level instrument is a key to successful survey. The trip bridge feather, a level bubble, and leveling screw to adjust the tripod level as necessary. An optical plumette on the trip bridge allows the surveyor to view the trip bridge center and place its crosshair precisely over the survey marker nail on the stake. Center the trip bridge on the tripod and attach it via the tripod connecting screw. While holding two tripod legs, keeping the tripod as level as possible, place the optical plumette crosshair over the center of the nail. And the last one is, with your foot, apply equal pressure along each tripod leg to ensure a stable connection with the ground. Step number 5 is continue to level and adjust the trip bridge as necessary. Viewing the level bubble, adjust the head of two tripod legs so that the bubble is close to center. Then use the trip bridge leveling screw for a more precise bubble level. Alternate back and forth between the optical plumette and level bubble to gain the most center and level position. You may need to loosen the center tripod screw to shift the trip bridge for a more center crosshair position. Step number 6 is set the instrument on the tripod. Remove the total station from the carrying case and secure it to the top of the trip bridge with the trip bridge instrument lock. Be careful with this step as the instrument can cost up to 25 million. Step number 7 is connect power supply and communication cables. Attach the battery pack to the tripod. Connect one cable from the battery pack to the instrument connection port. Connect the other cable from the battery to the swivel controller. Step number 8 is power on the instrument and controller to access the fine level. Press the black button on the instrument to power it on. Press the green button on the survey controller to power it on. On the survey controller, use the stylus to open the survey controller program. The software will open file leveling automatically. For the last step, fine level the instrument and composite. To fine level the instrument, turn the total station so that its face plate is parallel with two trip bridge leveling screws. These two screws will be used to adjust the trunnion left and right and sighting forward and back. Now that the instrument has been successfully leveled, press the accept button so that the instrument can perform its composition action. The total station is now ready to begin surveying operation. The last one is EDM procedure. Number 1 is set the target. Number 2 is, in the first page of OBS mode, press mid to start distance measurement. When measurement start, EDM information, distance mode, prism constant, correction value, atmospheric correction factor is represented by a flashing light. Next is a short beat sound and the measure distance data SD, vertical angle ZA, and horizontal angle HAR are displayed. And the last one is press stop to quit distance measurement. That's all from me. Thank you.